Good morning, class. Our topic today is curing, smoking, drying, and dehydration. Curing preserves the raw materials using different ingredients, seasoning, and extenders. Curing is a method of preserving selected raw materials into processed products like salted eggs, sausage, skinless longanisa, bacon, tocino, and many others. Enhance the taste and color of meat. Increases the water-binding capacity of the meat. Salt extracts moisture, prevents bacterial spoilage. Pink salt or Prague powder, a mix of sodium chloride and nitrate/nitrite, controls botulinum toxin. Sugar reduces salt's harshness, prevents hardening. Nitrate/nitrite preserves color, flavor, prevents spoilage and bacterial growth. Phosphate boosts yield, moisture. Ascorbic acid/sodium erythorbate retains meat color. MSG enhances taste, aroma. Textured vegetable proteins added to meat. Spices add flavor. Dry curing uses salt as preservative. Pickle curing uses sugar, vinegar immersion. Injection curing injects brine solution into meat muscle. Use appropriate container to prevent oxidation, contamination. Consider curing time. Maintain temperature at 36 to 40 degrees Fahrenheit. Regularly inspect for spoilage. Ensure even distribution of curing mixture. Freeze cured product for storage. The smoking process involves exposing cured meats, poultry, game, and seafood to smoke generated from burning hardwood chips, herbs, fruit skins, or spices in a controlled environment. This imparts flavor, aroma, texture, appearance, and extends shelf life. Smoking can occur between 65 degrees Fahrenheit to 250 degrees Fahrenheit, with cold smoke infusing flavor and hot smoke cooking the food. Temperature of smokehouse: 70 degrees Fahrenheit to 100 degrees Fahrenheit. 80 degrees Fahrenheit is the average temperature. Result of cold smoking: product does not cook. Slight dehydration of overall texture. Sausage in the uncooked smoked category, smoked salmon. Addition of smoke to an item that will be finished by some other cooking method. Final internal temperature of cured hot smoke products. All poultry 165 degrees Fahrenheit internal. All meats 155 degrees Fahrenheit internal. Final internal temperature of uncured hot smoked items. Beef, suitable cuts, 130 to 135 degrees Fahrenheit for rare. To produce a fully cooked, smoked item, sausage in the smoked cooked category. Preservation: antimicrobial compounds in smoke affect surface bacteria, but penetration is limited. Acids: smoke coats meat, aiding surface coagulation and preventing mold and bacteria growth. Flavor and aroma: phenols, carbonyl compounds, and organic acids contribute to smoky taste, but excess can lead to bitterness. Color enhancement: carbonyl compounds combine with meat proteins, creating reddish-brown hues characteristic of smoked products. Product innovation: smoky flavor extends shelf life and improves appearance. Oxidation protection: smoke guards against lipid oxidation and stale flavor. Protective coating: acids in smoke help form a protective protein skin on meats and emulsion-type sausage. Preparation of cold smoking: preparation before smoking. Trim item: truss, net, or tie as necessary. Cure item by desired method. When cure is done, rinse item. Form pellicle. Smokehouse preparation. Place items on racks or hang from sticks. Smoke process. Smoke foods until desired color/flavor is achieved. Product can be air-dried further if a drier product is desired. Refrigerate. Preparation of hot smoking. Preparation before smoking. Trim item, truss, net or tie as necessary. Cure item by desired method. When cure is done, rinse item. Form pellicle. Smokehouse preparation. Place items on racks or hang from sticks. Smoke process. Solid meat 185 degrees Fahrenheit smoked until proper internal temperature. Sausage 160 degrees Fahrenheit smoke until 140 degrees Fahrenheit internal. Finish by poaching in 170 degrees Fahrenheit water until proper internal temperature. Drying and dehydrating fruits and vegetables is an ancient preservation method, reducing water content to 75 to 90%, which lowers water activity, making them resistant to spoilage. Heat, typically from solar energy or hot air, removes moisture, but can result in texture loss, nutrient depletion, discoloration, and flavor loss. Water activity reduction controls chemical and microbiological changes. Decreased weight, size, and volume ease transportation. Simple, cheap packaging requirements. Facilitates further processing, like grain drying for flour production. Hot air evaporates water from food surfaces. Water vapor diffuses through air boundary and is carried away. A gradient from moist food interior to dry air drives water removal. Shrinkage. Moisture loss reduces food size and density, causing internal stress and shriveling. Rapid drying improves texture. Case hardening. Formation of hard outer layer due to rapid initial drying, common in solute-rich foods. Lower temperatures prevent it. Browning. Color change due to enzymatic oxidation, residual enzymes, Maillard reaction, protein amino and sugar interaction, or caramelization, sugar conversion. Hot air drying includes spray drying, tray drying, fluidized bed drying, etc. Spray drying involves atomizing pre-concentrated food into fine droplets and spraying them into heated airflow. Tray dryers use insulated cabinets with mesh trays and blow hot air through ducts for uniform drying. Microwave drying utilizes microwaves for drying. Freeze drying, lyophilization used for heat-sensitive foods, freezing material and then reducing pressure to allow frozen water to sublimate into vapor. Osmotic drying involves immersing high-moisture products in concentrated solutions, sugar or salt, to initiate countercurrent mass transfer. A timeless preservation method. Purpose: dehydration extends food shelf life by removing water content, making it one of the oldest and most widespread preservation techniques. Spoilage prevention. Moisture is a breeding ground for microorganisms like bacteria, yeast, and molds, leading to food spoilage. Dehydration prevents their growth by reducing moisture and slowing enzymatic reactions. Dehydration basics. Successful dehydration requires heat, around 140 degrees Fahrenheit, dry air to absorb moisture, and air movement to carry away moisture. Bacteria reduction. Processing methods like drying and pickling dehydrate food, altering pH levels and inhibiting harmful microorganism growth. Extended shelf life. Food processing enhances shelf life, reducing waste and promoting food sustainability. Health benefits. Processing reduces health risks by eliminating harmful bacteria and addressing major health concerns. Directions. Complete the crossword by filling in a word that fits each clue.